pump in a hydraulic system pumps hydraulic oil through the system over towards the actuators, and we need something to control the direction of flow, and for that we have a directional control valve. And let's look at primarily how to draw the symbols of those. Now just an overview. A hydraulic valve has a body, an outer chunk of metal, and then there are cavities and passageways inside that the oil flows through, and the whole deal is connected by this movable part which is known as a spool. And you can see here in this schematic, this diagram, that it's got some larger diameter lands that can block a port, and some open places in the middle of the spool that can, as you see in the bottom picture, let oil flow through. One of the words we use when we talk about these valves is way. Is this one way, two way, four way, so forth. And way means how many ways can the oil flow. So we're going to focus on four-way valves, but just to get us started, a one-way valve would be something like a check valve, where the oil can only flow one way through the valve, that's it. A shut-off valve could give the oil two ways to flow, in and out as well as off. A three-way valve is what you might find on a single-acting cylinder where you have a hydraulic jack under a house. But we're going to focus on four-way valves, and it's called four-way because there are four ways for the oil to flow. And the way you tell that is you count how many ports are there, how many openings are there into the valve. So if there are 4 ports, it's a four-way valve. Here are what some four-way valves look like. And four-way valves are used when you have double-acting cylinders. So you can extend the cylinder or you can retract the cylinder. And the specialty of this four-way valve is that it can reverse the flow so that you can extend or retract. When we draw symbols of directional control valves, we put together squares, and each square is called an envelope. That's the basic symbol. Each envelope is one position of the valve. The valve can shift over this way and that envelope will be in position, or it can shift back the other way and that envelope will be in position. If there are 2 envelopes, it's a 2-position valve. If there are 3 envelopes, it's a 3-position valve. Then, to describe how many ways in the valve, you count how many ports. So here is a thing with 2 ports in each envelope, so that's a 2-way valve. Here's a thing with 3 ports in each envelope, so that's a 3-way valve. And here at the bottom is a thing with 4 ports in each envelope, so that's a 4-way valve. 4 ports in each envelope, 4-way valve. Here's a hydraulic schematic, and in a schematic you show the valve symbol in just one position. Usually you show it in the position it would be in if it were just sitting in a box on your shelf. But what you will notice here about these ways for the oil to flow is that when you have the pump pumping oil through one way, it can enter a port in one end of the cylinder. So with the valve in this position, the oil comes in the piston end of the cylinder and will cause the thing to extend, and the oil that's squeezed out of the rod end of the cylinder will get squeezed back down through this other passageway and will return to tank. And this U-shaped thing here at the bottom of the line is the symbol for tank. We have 3 symbols here, even though we only have one tank. You show a symbol every place where there's a line that goes back to the tank, and this is just a way to keep the drawing clean so you don't have too many crisscross lines. Now, to picture what happens with this valve when you shift to the other position, let's look at the schematic on the right. Now we have shifted the valve to the left, so that now the oil coming from the pump goes across these two ports, across this way, up into the rod end of the cylinder, causing the cylinder to retract. And the oil that gets squeezed out of the piston end comes back down this line into this other way through the valve and drains back to tank. So you see how these two positions, these two envelopes in the symbol, show us which way the oil can possibly flow as the cylinder is extending or retracting. And then in addition to these envelopes, these squares, we add symbols on each end of the envelope to show how it's actuated, what operates the valve, what makes it go back and forth. And here are some symbols that represent some of the common ways. So let's look at those. And let me back up here. Let me point at this one right here. That's a symbol for a solenoid, that smaller square with a diagonal line through it. Or here it is down in the lower left corner. So a solenoid is an electromagnetic device that where a magnetic field causes a plunger to move back and forth, and that operates the spool in the valve. So here's a solenoid. Here's a kind of a diagram of a solenoid. You have coils of wire wrapped around a core, and then when electric current goes through the wire, that causes a magnetic field, and that causes the plunger in the solenoid to move, and that moves the valve. Here is a symbol, two-position valve with a cam roller that actuates the valve. So here's the cam roller. You might see that in, let's say, a plastic injection molding machine. Then here on the other end is a spring, and in the section view there's a section through the spring. So this is a spring return. It's a cam roller actuated spring return. Here's a three-position valve where we have a lever actuated. Here's the lever. It's lever actuated on each end, and then it's spring centered. Notice the spring on each end of the symbol, and in our section drawing there's a spring in each end of the valve. So all other things being equal, the springs on each end will cause the valve to be in the centered position. Here's a valve that's a two-position valve. It has a solenoid symbol up here, so there's the solenoid. It's solenoid actuated, and it's spring return, so there's the spring return in the other end. Here's one that's mechanically actuated on each end, but one end has these notches with this spring, this pin on a spring, and so that's a detent, mechanically actuated. Here's a symbol for a three-position valve. It's spring-centered because it has a spring on each end, and these two symbols with the arrows mean it's pilot operated. I'm going to show you in the next slide what a pilot is. So this one is pilot operated with hydraulic fluid. The one down below is pilot operated with air. When that arrowhead, that triangle, is not filled in, that means it's pneumatic. It's air that comes in and operates the pilot. And then this one also is spring-centered. I was going to tell you about the pilot, but I think I'm going to tell you about the pilot later. So first, sorry about that. First, some centering conditions. In a three-position valve, you'll have various center conditions where the valve can be shifted there and something or other happens. In an open center, which looks like this in the envelope symbol, in an open center, the flows go from the tank through the valve back to tank again. So here's an open center. Here's a closed center, and you can see in this section view the lands on the spool are blocking the ports. Here's what the symbol looks like. Each line coming from a port has a short line crossing it off. It's blocked off. So this is a closed center. Those ports are blocked. Here's a tandem center where two ports are blocked. The other one comes from the pump and goes back to tank again. And here's a schematic where all three valves are tandem center. Here's a float center, which can be used to maintain some pressure on the thing without moving the cylinder. So there's a float center. Here's a schematic symbol of it. All right, here's where I wanted to talk about pilots. We talked earlier about solenoids for operating valves, and here at the bottom of this slide is a picture of your average valve with a solenoid on top. So now, when you're out in the shop looking at hydraulic stuff, when you see a thing that looks like this, you will be someone who knows you are looking at a valve with a solenoid on it. And that's a common way of shifting small valves. However, big valves, they just require a lot of force to shift. There's a lot of oil, and you know about our calculations earlier this term about pressure, force, and area. So you know that with a bigger area, we've got bigger force. Anyhow, with a big valve like this one in the picture, if you just put a little solenoid on there, you would probably not have enough force to shift that valve. So what you do is you add a smaller valve, and that smaller valve is called a pilot valve. So what happens is the solenoid shifts the pilot valve, and the pilot valve has enough force to be able to shift the big valve. That's called pilot operated. It's analogous to the idea of a trim tab on a big ship's rudder. So a big ship engine does not have enough force to turn the rudder to turn the ship, so they have a little small rudder, a little trim tab in the middle of the big rudder, and that turns, and then that gives enough directional flow to turn the rudder. I think of this pilot pressure as kind of analogous. And finally, just for your reference, here are some symbols all strung together of various positions and ways for various valve symbols.